Sorry guys, I just just forgot to record this session. Anyway, okay. All right, now in the next step, I'm going to take this one to either side of the inequalities, right? So if you do that, this is what you will get. Excuse me. Okay. Okay, now because of the argument that what happens to the -1? Oh, okay, okay, thank you. Thank you, look at that. Thank you. Thank you for that. Yeah, now because of the argument that I made in the previous question, right? This guy here must have the standard normal distribution, right? You remember the argument that I made, which is in this box here, right? That anything of this form must have the standard normal, right? So in this question, this must have the standard normal, right? Okay, so this is the probability that right, this is less than or equal to n01, right? And is less than or equal to okay. Okay, once again, we don't need the conditioning here. The conditioning, we have used the conditioning to argue that this has the standard normal, right? Therefore, we don't need it anymore, right? All right. So the next step, in the next step, I'm gonna, excuse me, I'm gonna use the phi function because what you have here, excuse me, what you have here, guys, is the difference of two phi functions. So this is simply phi at 1 point, um, 1 point, okay, and take away phi at minus 1.96 minus yeah. All right, so this is what you get, and you should work this out using a calculator or some other means. The answer that you will get is 0.24. Okay, all right. All right, guys, so that completes question number 2 of the tutorial sheet. Right, the next question on this, okay, let me take this away. The next question is this. is this one here. So you have two different drugs, A and B. Drug A is given to 33 people. Drug B is given to 37 people, right? And so these are the numbers that the two drugs are given to, and these are the sample sizes, and these are the sample variances. And we want to test at the 5% significance level whether there's a difference in the mean times of absorption for the two drugs, right? And there are two parts to the question. The first part is to assume that the population variances are not equal. The second part is to assume that the population variances are equal, right? All right, now, as I said before, the first thing you must figure out is which test to use, right? Because in this question, the question says explicitly that the sample variances are given, which means automatically that the population variances are unknown. That is, they are not known, okay? So in other words, you cannot use case one. Remember, case one corresponds to the population variances being known. So none of these rules can be used, right? None of these rules can be used. Now let's go to case two. Case two is where the two population variances are equal and unknown. This cannot be used again because in part one, we are assuming that the population variances are not equal, right? So case two cannot be used either, right? So let's go to case three. Case three is where the population variances are not equal and unknown. So this is the case that you need to use to answer part one, right? And since we are testing for a difference in the mean times, right? The rule that we need to use is this one, right? So this is the rejection rule that we need to use in order to answer the first part of question 3, okay? All right, so let me write that down now. Okay, so I'm gonna write that down, what I just said, okay? So this is question 3, part 1. So we reject H0 if right? So let me put this in a big box. Right, let me call this star, right? All right, now the first thing I'm going to do is I'm going to write down all the data that's given to us, right? So we are told that M is 33, N is 37, X bar is 28.2, Y bar is 30.7, SX squared is 16.36, SY squared is 18.92, right? And alpha is 5%. So this is all the data that's given to us, all right? So now I'm gonna put this data into this. So let's, the left-hand side of star is gonna be as follows. Okay. Now, if you work this out using a calculator, right? You will get this to be equal to 2.4049, 2.49. Okay, so let me, okay. Now the right-hand side of star is gonna be TA. Alpha is 5%, so it's gonna be 0.975, right? Okay, now let's try to read this. The problem with this is that, okay, let me show you. Because remember, A is the degree of freedom, right? And the formula for A is given by, I think I gave it to you before, is given by this expression here. This is the formula for A. And as you can see, it's really, really complicated, right? I mean, it can be computed, but it will take you a while, especially in an exam, right? So if you can, so it's best to avoid using this formula for computing the right-hand side. Now, what I'm going to say is the following. I think I made this argument before, right? Because can you look at the sample sizes, which are 33 and 37, right? And in statistics, anything above 25 is considered large, right? And for large sample sizes, the T percentile can be approximated by the Z percentile. I think I mentioned this before, right? I mean, for large degree of freedom, the T distribution approaches the standard normal. So the T percentile can be approximated by the Z percentile, right? And this is much easier to read than this one. And this, as you know, is equal to, if you read it, this is what you will get, 1.96. All right, so this is 2.49 and this is 1.96. So this is clearly greater than 1.96. So the conclusion is that there is evidence to reject the null hypothesis, right? All right, guys, so that's the, so is this okay with you guys or not? Please let me know. So the only trick I have used here is the approximation of the T percentile by the Z percentile. That you can do if you have large sample sizes. So in this case, we do, because 33 and 37 are large. I mean, anything about 25 is considered large. Okay. Oh yeah. Okay. Okay. Thank you, guys. Are you okay with this or not? Please let me know if you have questions. Hello. Okay. Thank you. All right. The next question. Okay. The next part. I mean, so I've done the first part of the question 3. The second part is it's the same thing, but assuming that the variances are equal, right? Now, in this case, I'm gonna, okay, go back to the formula sheet. You should remember this one, all right? This is case 2, where we're assuming that the population variances are equal and unknown. And in this case, the rule for this hypothesis is this one. So I'm gonna use this for doing part 2 of question 3, right? Right, so let me show you that. So let me move to, so here we are. Get a piece of paper. So I'm gonna do, this is question 3, part 2. So the first thing I'm gonna do is to write down the rule for rejecting the null hypothesis, right? Which is the following. Right, let me put this in a big box, right? as usual. All right, and let me call this star. Okay. Right, the left-hand side. All right, before I compute the left-hand side, you guys remember this. This is the pooled sample variance, right? It's known as it's known as the pooled sample variance, and it's defined to be, if you look back in the video, you will see the definition. It's defined to be this. Okay, and this is equal to M is what? M is, let me try to recall, what was M? M was, here we are. Okay, M was 33, right? It was 33 minus 1 times the sample variance was 16.36. N was 37 minus 1 and times the sample variance, which was 18.92, and divided by 33 plus 37, take away 2, right? And if you work this out, you would get 17.715. Okay, that's the pooled sample variance, right? Now, to compute the left-hand side, you just, of star, you just sub in the numbers. So it's gonna be 28.2 x bar, y bar is 30.7 divided by 17.715, 1 divided by m is 33, n is 37, right? So this is this is the left-hand side, and if you work this out, you will get 2.481, right? Now the right-hand side of star is this guy here, right? Which is T, M is 33, N is 37, take away 2, alpha is 0.05, so it's 0.975. Now, you may argue that this number is big, so you can approximate this by a Z percentile. But, I mean, there's no need to do that because this is really easy to read, right? I mean, this is actually 68. Sorry, 68, right, comma 0.975, which is, you can easily read this off the T table. I'm sure you guys know where the T table is, right? It's in the course website. You can easily read this in the T table. I mean, there's no need to approximate this by the Z. I mean, in the earlier case, we did because A was a complicated expression. That's why we approximated the T percentile by the Z percentile. But in this case, we don't need to do that really, okay? Okay, so this, if you read it off the table for the T, this is what you will get. So this is the right-hand side and this is the left-hand side. And once again, the left is greater than the right. Okay, so the conclusion is that there is evidence against the null hypothesis, right? Are you guys okay with this or not? Please talk to me, guys. Hello, you guys okay? All right, so this completes question number 3, right? Right, so there are 2 remaining questions. Unfortunately, I don't have the time to do them today, but I will post the solutions to all 5 questions later today in the course website. So you will see them, right? The typed solutions, the handwritten solution, and the video solutions for all 5 questions. All right, so as you know, today is the last tutorial. It's really been an honor teaching you guys, and I mean, please do keep in touch. And as I said, I'm here throughout the summer, and all the questions you have for the exams, you can contact me 24/7 by email, Skype, Zoom, or phone. I'm also happy to meet you in anywhere in Manchester and go through problems with you. Okay. So please take care and have a good time. And by the way, about the art coursework, the deadline is over. I spent the whole of last night and this morning marking. I'm still marking over 500 papers. As I mean, as I told you, I do all the marking. I don't use any teaching assistants for my marking. Um, so I hope, I don't know how long it's going to take, but I will try to get your marks and the feedback to you as soon as possible. And yeah, I will also send you copies of your report with my comments by email to you, right, individually. So anyway, hopefully sometimes next week or maybe earlier. I don't know. Okay. All right, guys. Have a good time wherever you are, and take care. Take care of yourself. Right. Okay, guys.
Thank you, sir.
Thank you. Thank you, man. Take care.
Thank you.
Thank you. Yeah.